Hey guys, so let's go ahead and review today's lesson. So what you can see here is the problem of the day, and I've already filled this out, and I filled it out based on what I already know. So starting with 4 to the 0 power and 4 to the 1 and 4 squared, I have 4 and 4 times 4, which is equal to 4 and 16. I know that any exponent raised to the 0 power is going to be equal to 1, and from there I know that as I'm working up, I'm going to be dividing by my base of 4, which is why here I have 1/4. Here I have 1 over 4 times 4, or 1 over 4 squared, or 1 over 16. And here I have 4 to the negative third power is 1 over 4 times 4 times 4, or 1 over 64. Or if I wanted to write it this way, I could do it as 1 over 4 cubed. So I can see my powers here, -3, -2, -1, 0, 1, 2. I can see my pattern here of 1 over 4 cubed, 1 over 4 squared, 1 over 4, 1, 4. And I can see my pattern here of 1 over 64, 1 over 16, 1 over 4, and then the same numbers, 1, 4, and 16. So this is a review of what we did yesterday. So today was a little bit of an experiment. And we started by kind of looking at this expression and just seeing, well, could we figure out what this answer was? So what a lot of kids said, well, yeah, I can figure out what this is. I can figure out that 4 times 4 is equal to 16. And I can figure out that 4 times 4 times 4 is equal to 64. And if I multiply 16 times 64, I'm going to get 1024, and that would be my final answer. But if I wanted to keep it in exponential form, well, I can see I have 1, 2, 3, 4, 5 4s. So as an exponent, that is going to be 4 to the 5th power. So if I expand this one here, I'm going to end up with the same thing. Well, not the same answer, but it's going to be the same process. So I have 3 times 3 times 3, which is equal to 27. And then I have 3 times 3 times 3 times 3, which is equal to 81. And if I multiply these two together, I'll get my answer. But if I want to know how many 3's I have, 1, 2, 3, 4, 5, 6, 7, I have 3 to the 7th power. So what I'm starting to see here is that basically what's happening is because I'm expanding these numbers out, I'm basically adding my powers. I'm adding the number of 3's that I have. Here I have 2 to the 4th times 2 to the 5th. Well, I can expand that out. 2 times 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 2. And how many 2's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So my answer here is 2 to the 9th power. Sorry, it's showing my hand. All right, so let's look at a bigger number here. I'm starting to come up with a rule here. I know that it's going to be 10 to the 10 plus, well, not plus, but it's going to be essentially that. And what I'm going to end up with is 2 to the 12th. Okay, so the product rule says any exponent to a power multiplied by an exponent with the same base is going to be equal to a to the b plus c. So what that means is when given an exponent with like bases and the numbers are being multiplied, add the powers to find the exponential form. Okay, so we can look at just a couple of examples on the self-check. We're going to go ahead and skip this for now. So if I have 4 squared times 4 cubed, what I have is 4 times 4 times 4 times 4 times 4, which is equal to 4 to the 5th power. Same thing here. 7 times 7 times 7 times 7. 7 times. 1, 2, 3, 4, 5, 6, 7 times 7 times 7 times 7. How many 7s do I have? I can see exactly how many 7s I have. 10 7s. So that is the product rule, and tomorrow we're going to work on negative exponents and dividing